Your sun, the star keeping you alive right now, is ranked as one of the most dangerous types of stars, and it's not even the worst. 7 types of stars. Some invisible, some gentle, some so massive they explode when they die and leave behind black holes. And one of them is a ticking time bomb sitting 100 million miles from your face. By the end of this video, you'll know exactly how each type would kill you, which one's the most dangerous, and why our sun is ranked way higher on that list than anyone's comfortable admitting. So here's something that blew my mind when I first learnt it. Not all stars are the same, like at all. We look up at the night sky, see a bunch of white dots, and think stars. But that's like walking into a zoo and going animals. No, there are 7 completely different species of star out there. Some are tiny, barely bigger than Jupiter. Some are so massive that if you replaced our sun with one, it would swallow the orbits of every planet up to Saturn. Some burn cool and red for trillions of years. Others burn blue hot and die in a few million years, barely a blink in cosmic time. And the way astronomers classify them is honestly one of the funniest naming disasters in the history of science. Back in the 1800s, astronomers started sorting stars by how much hydrogen they could detect in their light. They labeled them A through Q. Clean, alphabetical, made perfect sense. Then a woman named Annie Jump Cannon came along and ruined the whole thing in the best way possible. Annie was an astronomer at Harvard who single-handedly classified over 350,000 stars by hand. No computers, just her, a magnifying glass, and photographic plates. She realized the old alphabetical system was completely wrong. Stars shouldn't be sorted by hydrogen, they should be sorted by temperature. So she rearranged the classes from hottest to coolest, but she kept the original letter names, which gave us this beautiful mess: O, B, A, F, G, K, M. If you're wondering how astronomy students remember that, here's the mnemonic. Oh, be a fine girl, kiss me. I didn't make it up, Annie did. Astronomy has range, I'll give it that. Our sun is a G-type, right in the middle. Not the hottest, not the coolest, solidly average. But here's the thing, average doesn't mean safe, not even close. We're going to go through all 7, from the bottom of the temperature scale to the top. And I promise you, the one you think is the least dangerous might be the most terrifying of all. M-type stars are the smallest, coolest, and dimmest stars in the universe. They glow a faint red. Some of them are barely bigger than Jupiter. And here's the first mind-blowing fact of this video: 76% of all stars in our galaxy are M-types. More than 3 out of every 4 stars. They are literally everywhere. But here's the catch: you can't see a single one of them with your naked eye. Not one. They're too dim. The entire night sky you admire, that's the other 24%. The majority of the galaxy is invisible to you. Now you'd think being small and dim makes them harmless, right? Quiet kid in class, never causes trouble, keeps to itself. Wrong. M-type stars are absolute menaces. They throw tantrums, massive bursts of radiation called stellar flares that are proportionally way more violent than anything our sun has ever produced. Proxima Centauri, the closest star to our solar system, is an M-type, and it regularly blasts its planets with flares so intense that any atmosphere would get stripped away like paint in a sandstorm. Remember the TRAPPIST-1 system? 7 Earth-sized planets. Everyone got excited. Maybe there's life. Yeah, they orbit an M-type. Those planets are probably getting sterilized on a regular basis. But here's where it gets really interesting. M-type stars live almost forever. Some will burn for trillions of years. The universe is only 13.8 billion years old. Not a single M-type star has died yet. Ever. Not one since the Big Bang. Which means if life could somehow survive the flares on an M-type planet, it'd have trillions of years to evolve. 1,000 times longer than Earth has existed. Imagine what life looks like after a trillion years of evolution. So M-types are simultaneously the most violent and potentially the most important stars for life in the entire universe. K-types are the stars scientists genuinely get excited about and literally nobody else cares, because K-types are boring. And in astronomy, boring is a compliment. They're orange, a bit cooler than our sun, and they live for 20 to 30 billion years, more than twice the sun's lifespan. Stable, calm, zero drama. Scientists call them Goldilocks stars, habitable zones in the perfect range, not too much radiation, not too little warmth. If you were designing a star from scratch to support life, you'd build a K-type. They're basically the Honda Civic of the stellar world. Nothing flashy, just reliable for an absurdly long time. Your friends won't be impressed, but you'll outlast all of them. In terms of danger, K-types are about as threatening as a librarian, which is exactly why nobody makes videos about them. But remember, they exist, because everything from here on gets progressively scarier. Alright, let's talk about the one we all know. G-type, yellow dwarf. Our sun, the star you owe literally everything to. G-types are a step up from K-types, hotter, brighter, more energetic. They live about 10 billion years. Our sun is roughly 4.6 billion years old, so think of it as middle-aged, stable phase. For now. From Earth, the sun looks pretty chill, right? Warm, reliable, always there. Every sunrise, every sunset. A friendly neighborhood star. But here's what they don't teach you in school. The sun is a barely controlled thermonuclear explosion. It converts 4 million tons of hydrogen into pure energy every single second. 4 million tons per second. And sometimes it glitches. In 1859, the sun fired off a massive burst of charged particles, the Carrington event. Telegraph systems worldwide caught fire. Operators got electric shocks. Auroras lit up the sky as far south as the Caribbean. In 1859, our most advanced technology was telegraph wires. Today, it's power grids, satellites, GPS, the internet, banking, hospitals. If a Carrington-level event hit today, estimates range from $600 billion to $2.6 trillion in damage. In a single day. And here's the part that should genuinely concern you. In July 2012, a solar storm just as powerful actually fired off from the sun. It missed Earth by about 9 days of orbital rotation. 9 days! We didn't dodge a bullet, we dodged a nuclear warhead. Most people never even heard about it. But that's short-term danger. The long game is worse. The sun is getting hotter, about 10% brighter every billion years, slowly, steadily cooking us. In about 1 billion years, the oceans boil. In 5 billion, the sun swells into a red giant and swallows Mercury, Venus, and possibly Earth whole. G-types, middle of the road, perfectly safe until they're not. But compared to what's above G on the scale, our sun is practically a pacifist. F-types are yellow-white, hotter than our sun, 1.5 to 5 times brighter. They live around 2 to 4 billion years. Think of F-types as the sun's more aggressive older sibling. Same general vibe, but pushier. More radiation, more UV, shorter fuse before things go bad. Planets can exist in their habitable zones, but life would need to speed-run evolution. 2 billion years instead of 5. Good luck building a civilization in that window. F-types are the dividing line. Everything below M, K, G at least has a fighting chance of supporting life. Everything above this? A-types are where stars start getting genuinely beautiful, pure white, 7,500 to 10,000 Kelvin. If stars had a runway, A-types would be walking it. These are the stars you actually recognize. Sirius, the brightest star in the entire night sky, A-type, Altair, spinning so fast it's literally bulging at the equator. They're about 1.5 to 2 times the size of our sun, and anywhere from 10 to 50 times brighter. And they've got this clean, almost surgical white light. Now here's where the problem starts. A-types live maybe 1 billion years. Some don't even make it that long. Sounds like a lot, right? It's not. Life on Earth took 3.8 billion years just to go from single-celled organisms to anything with a spine. An A-type star would be dead before the first fish showed up. And the UV they pump out is brutal. We're talking 10 to 50 times the sun's luminosity, most of it in ultraviolet. Any planet in the habitable zone would need a magnetic field and an ozone layer thicker than anything Earth has. A-types are the pretty ones, but pretty doesn't mean safe. And compared to what comes next, A-types are practically polite. B-types. Now we're getting into the heavyweight class. These are blue-white giants, 10,000 to 30,000 Kelvin, 2 to 20 times the mass of the Sun. Some of them are tens of thousands of times brighter. Rigel, that bright blue-white star in Orion, a B-type, roughly 120,000 times more luminous than the Sun. You could see Rigel from 800 light-years away, and it still looks like one of the brightest stars in your sky. That's absurd. B-types are so hot and so luminous that they generate stellar winds powerful enough to physically blow away material from nearby space. We're talking winds at 2,000 to 3,000 kilometers per second. Planets don't form around these stars. They can't. And their lifespan, 10 to a few hundred million years. Some of them barely last longer than the dinosaurs did on Earth. They burn through hydrogen like it's going out of style, and when they die, they go as supernovae. Massive explosions, neutron stars left behind, sometimes black holes. B-types are the warm-up act for the most dangerous type of star in the universe. If O-types are the final boss, B-types are the boss right before that, the one that kills you enough times to make you nervous about what's coming next. They live a few million years, some don't make it to 10 million. They burn through fuel so fast that most planets wouldn't finish forming before the star is already dead. When O-types die, some go as hypernovae, explosions that release more energy in 10 seconds than our Sun will produce in its entire 10 billion year lifetime. These hypernovae can produce gamma-ray bursts, focused beams of radiation that sterilize entire solar systems from thousands of light years away. One O-type death could wipe out life across an entire region of the galaxy. Eta Carina, one of the most massive stars we know, might go hypernova soon. Soon in astronomy could mean tomorrow or 100,000 years from now. But when it goes, it'll be visible from Earth in broad daylight. O-types are the apex predators of the stellar world. Live fast, burn hot, die catastrophically, leave behind black holes. The fact that none are anywhere near us is probably the only reason you're watching this right now. So which of the 7 is most dangerous? After all of that, here's what I think. Most destructive overall, O-type, no contest. A single death can sterilize a region of the galaxy. Nothing else comes close. Most dangerous to the planets orbiting it, M-type. The twist nobody sees coming. The tiny invisible stars that make up 3/4 of the galaxy might be the biggest threat to habitability in the universe. But most dangerous to us, right now, today, G-type, our Sun, the one we trust, the one we built our entire civilization under without a second thought. Because the Sun isn't a friendly yellow ball, it's a thermonuclear reactor on a billion-year timer. And a well-aimed coronal mass ejection could set modern civilization back decades overnight. We got lucky in 2012. Luck doesn't last, but here's what I find genuinely remarkable. Out of all 7 types, from invisible red dwarfs to monstrous blue supergiants, we orbit one that sits right in the sweet spot, hot enough to sustain life, stable enough to give evolution 4 billion years, calm enough, most days, to not kill everything on the surface. We got genuinely lucky. Every star, no matter how gentle, eventually runs out of time. So maybe the real answer to which star is most dangerous is whichever one you stop paying attention to.